Hi everyone, welcome to another session of our short video series. In this video, you'll learn about scalar and vector quantities. In physics, we often deal with different types of quantities that describe the properties of object or phenomena. Some of these quantities are scalar, some are vectors. Quantities that are only concerned with magnitude, like how large or how heavy, are scalars, whereas quantities that are concerned with both magnitude and directions are vectors. The direction in vectors has an important purpose. Let's start with scalar quantities. What are scalar quantities? Scalar quantities are those that have only a magnitude or a size but no direction. Examples of scalar quantities are length, volume, mass, speed, energy, temperature, and work done. Vector quantities are those that have both magnitude and a direction. Examples of vector quantities are force, velocity, displacement, acceleration, moments, magnetic field strength. Why do we need direction information for vector quantities? Direction information is very important for vector quantities because it tells us how the object or phenomenon is moving or changing. For example, if we say that a car is moving at 60 kilometers per hour, we are giving its speed, which is a scalar quantity. But if we want to know where the car is going, we need to give its velocity, which is a vector quantity. Velocity tells us both the speed and the direction of the car. For example, we can say that a car is moving at 60 kilometers per hour north, or 60 kilometers per hour east, or 60 kilometers per hour at an angle of 30 degrees from the horizontal. Direction information is also important for vector quantities because it allows us to add or subtract them. For example, if we want to find the net force acting on an object, we need to consider both the magnitude and direction of all the forces. We cannot simply add or subtract the magnitude of the forces because they may be acting in different directions. For example, if a 10 Newton force is acting to the right and a 5 Newton force is acting to the left, the net force is not 15 Newtons, but 5 Newtons to the right. We need to take into account the direction of the force when we add or subtract them. How do we draw and interpret vector diagrams? Vector diagrams are graphical representation of vector quantities. We use arrows to show the magnitude and direction of the vectors. The length of the arrows is proportional to the magnitude of the vector, and the direction of the arrow is the same as the direction of the vector. For example, a 10 Newton force to the right can be represented by a 10 centimeter arrow pointing to the right, and a 5 Newton force to the left can be represented by a 5 centimeters arrow pointing to the left. That's all for this session on scalars and vectors. Be sure to check out more of our videos.